Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and I'm also an AWS ambassador. StratusGrid is an AWS Premier Consulting partner. We're also an independent software vendor, and we have a SaaS platform called Stratosphere that helps large enterprises to identify cost savings opportunities across their AWS cloud environments. So if you're interested in seeing Stratosphere, head out to our website at stratusgrid.com. There is a product section here that talks about the FinOps and future SecOps capabilities that will be available in Stratosphere. And feel free to reach out to us if you'd like to see a demo of Stratosphere. Just to give you a really quick insight into how it looks before we get into the topic for this video, Stratosphere has several different views that allow you to see kind of a high-level overview of your cloud spend and your operating efficiency level, which is this orange dashed line right here. So we want to see our efficiency trend downwards over time, of course, as we implement more and more cost savings opportunities. And if you're looking for where the most cost savings opportunity is, you can break it down on a per AWS account level. You can also break it down into the level of effort required to remediate various savings opportunities. And then there's these quadrant views that really allow you to narrow down where the largest savings opportunities are based on which AWS account ID you have, as well as the service. So oftentimes the services like EC2 and RDS, Elasticache, and other large compute services like that tend to be outliers where there's a lot of savings opportunity, but there's also a lot of savings opportunity in other services as well, like S3 and Lambda and many other services that you might not really think about as being mainstream spenders. We also have a findings view and an analysis view. So in the analysis view here, you can see a breakdown of the various types of discounts that are being applied on a per service or per account level, depending on how you want to group that data. You can also apply a filter to see specific services that you are interested in understanding your current spend and operating efficiency on. You can see things like your private purchase agreement with AWS, your enterprise discount plan, being applied to your monthly cycle here. And so there's a whole bunch of information here that helps you to see what discounts are being applied, as well as the potential savings broken out by service or again by AWS account. And then lastly, we have a findings view, and these are all the individual line items of resources that you can actually take action on to remediate the cost savings in your environment and realize a gain on that. So if you're interested in seeing a demo of Stratosphere, feel free to reach out to us and we would love to walk you through how it can help you. Now, the topic for this particular video is going to continue on the Amazon Bedrock theme. And if you've subscribed to our channel, you probably have seen some other videos on Amazon Bedrock. We've covered Bedrock in a lot of different ways. We've talked about the Bedrock prompt flows feature before that became generally available. We've also talked about how to set up Amazon Bedrock knowledge bases so you can do retrieval augmented generation against various documents inside of a document store like S3, for example, and use a variety of different vector databases like MongoDB or Pinecone database or some of the others that are available from AWS, like the OpenSearch service. But what we're going to be talking about in this video in context of Amazon Bedrock is we're actually going to do a little bit of Rust coding. So we're going to be plugging into one of the key APIs that you should be aware of as a developer so that you can leverage foundation models inside of the Amazon Bedrock service. Now, if you're just getting started with Bedrock for the first time, or if you're brand new to large language models in general, hopefully you've at least had a little bit of exposure to things like ChatGPT and Claude AI from Anthropic and Grok from xAI and other models like Gemini from Google is another example. But there's just a huge amount of different large language model hosting services out there. But one of the great things about Amazon Bedrock is that it's really geared more towards developers. It's geared more towards enterprises that want to have a deep level of integration and customization that they can perform against large language models. If you're just looking for a consumer level model where you can just ask it questions about generic information on the internet and it just kind of goes out and searches web pages and maybe generates some code for you as a developer, maybe you're looking for some recipes on how to cook a really good steak or something like that, how to marinate it. You know, some of the base models out there like ChatGPT are great, or Google Gemini are great for that type of consumer oriented task. But when it comes to business, B2B type of tasks, where it's, checking status on projects, or, querying data that I've got in a proprietary database internally, or, allowing customers to run queries against AI models, you really need that deeper level of customization. And that's why Bedrock from AWS is a really powerful service, because they provide a lot of different functionality that allows you to code against large language models. You can even create what are called Bedrock agents that can perform automation tasks in conjunction with AWS Lambda. In fact, if you head out to our YouTube channel, where you're probably watching this video right now, we have a couple of videos on how to build Bedrock agents using open API specifications with Lambda, as well as how to just use the agent builder interface directly inside of the Bedrock console to create those agents. But what I really want to focus on for this particular video is not knowledge bases. We're not going to talk about agents. We're not going to talk about Bedrock prompt flows or anything of that nature. We're just really going to focus on, how do I use one of these pre-trained foundation models, like Claude 3.5 Sonnet is a really popular one. That's kind of my preference, or even Claude 3.5 Haiku, or there's the new Claude 3.7 Sonnet, which has extended thinking capabilities as well, which allows it to give more accurate results and reason through things. How do I actually use these foundation models as a Rust developer? And the great thing about the AWS ecosystem is that AWS publishes SDKs, or software development kits, for all sorts of different languages. So you could be a JavaScript developer, a TypeScript developer, a Python developer, a PowerShell developer. You could be a C# developer, Java developer, Golang, Rust. It really doesn't matter what language. There's pretty much an SDK for all of the different mainstream programming languages out there. And Rust is a great choice for software development, because it's very, very quickly gaining momentum, and it's a very high performance language with very efficient binaries that it produces. So if you build an application in Rust, you can produce a very lightweight binary that can run on lots of different platforms, and it utilizes your compute, your CPU power, and your memory, your RAM, very efficiently, as long as you are coding using memory efficient practices. But compared to some other languages out there, like the C#.NET platform or Java applications, the binaries that are produced by Rust are much, much lighter weight. And so therefore they can run on smaller devices, like embedded devices or mobile phones, potentially even things like Raspberry Pis, or low power compute devices. And you can actually save a lot on your cloud compute costs by reducing your EC2 instance size that maybe you're running on, so that you're not having to consume as many system resources, which ultimately results in cost savings for you. So from a cost management perspective, Rust can actually be an excellent choice of programming language. And because AWS provides a supported SDK for all of their different services, like Bedrock and EC2 and Lambda and CloudWatch and all the different service APIs that you can plug into, then we're going to be able to benefit as a Rust developer by being able to simply build on top of AWS. And in the Bedrock ecosystem, there's a specific API. There's actually several different kind of API groupings under Bedrock, but we're going to be focusing on one specific API called the Converse API. The Converse API is what you use to interact with foundation models. So if you have an AWS account, which you of course are going to need to have in order to follow along with this video, what we're going to do is go over to the Bedrock console here, and under the foundation models section right here, I'll just kind of collapse these other ones here so we don't have to worry about those too much, but we have this thing called the model catalog. And this is basically all of the models that are built into the Bedrock marketplace, right? So if I want to use any of these models, I can just use them directly through the Bedrock APIs. There is one thing you'll have to do first. If you go down to Bedrock configurations on the left and go to model access and click on modify model access, you will need to make sure that you check off any models that you want to have access to. So for example, right now, I don't have any of these Mistral models enabled. There's certain stable diffusion models I don't have enabled from Stability AI that do image generation, but I can go ahead and just check those off, click on next, and then submit my changes, and that'll either enable or disable access to each of those models. And the reason that that extra step is in there, where you have to go explicitly enable those, is because these third-party modules that are from providers like Anthropic or other providers like Cohere or Luma AI or Meta and all of these external vendors, these are actually being billed through the AWS marketplace. So that's why you have to go in here and say, you know what, I want to opt in to this third-party product, and I'm willing to pay for it through the AWS marketplace as part of my monthly AWS invoice. So that's why that extra step is in there, because these services are actually being kind of integrated with external third parties besides just AWS themselves. Most services in AWS don't have that extra step because most of the services are just developed and provided directly by AWS. And so there's not really any need to kind of opt in to that third party service. So once you've activated the necessary foundation models that you want, again, I would recommend using Claude 3.5 Sonnet v2 or Claude 3.7 Sonnet, or if you want a lighter weight model that's a little bit less expensive, you can use Claude 3.5 Haiku. That's quite a bit less expensive compared to the heavier weight models like Claude 3 Opus here. But once you've granted yourself access to those models, you can then start using them from the different APIs. So up here in the model catalog, we can filter down to some of the different models available. So I'm going to just filter down to Anthropic right here. And these are just some text models that I can use to send text tokens as input and then ultimately generate some output tokens to get answers to various types of queries. If you click on one of these models, it'll drill into the model details in the marketplace here, and then you can grab the model ID right here. And this is the model ID that we're actually going to specify inside of our application. And if you want to, you could actually copy several different model IDs that you want to use from your Rust client application, and you could maybe prompt the user to select which model they want to use. Maybe I want to be able to very easily switch back and forth between those models. Well, that's in those cases, I could just kind of prompt and specify a different model ID and then dynamically specify that whenever we call out to the Converse API. So that's all we're really going to be doing, is calling out to one of the foundation models in the model catalog. But I wanted to take you over to the documentation for Bedrock here. So let's search for Bedrock docs in AWS, and we'll just head out to that. And we're going to go over to not the user guide here, but we're going to go to the API reference section. And then, as I mentioned a couple of minutes ago, there are several different kind of API groupings under the Bedrock service. So we have Amazon Bedrock, which is just some foundational APIs that allow you to work with things like guardrails and exploring the foundation models. There's a list foundation models API here that you can actually use to list out all of the available models to you dynamically. So you can use that if you want to list them out instead of going into the console like we just did to get that model ID. But then there's agents for Amazon Bedrock. So this allows you to create and configure agents in Bedrock. But then if you actually want to call out to an agent to perform a query or to tell it to go do something, in that case, you actually use what's called the agents for Bedrock runtime. And that's where you have the functionality like invoke agent or invoke flow to invoke a Bedrock prompt flow. Or you also have this relatively new feature called data automation for Amazon Bedrock. And then down here, we actually have the Amazon Bedrock runtime. So Amazon Bedrock is kind of giving you this fundamental API list for kind of managing stuff inside the Bedrock service. But if you actually want to call a foundation model, that's what we call the Amazon Bedrock runtime set of APIs. And there are several different APIs under here, and we're, again, going to be focusing on Converse, or you could also take a look at Converse Stream. Now, the reason we're going to focus on Converse instead of Converse Stream is because there's already a lot of complexity in these API calls, and I don't want to overly complicate this for you right now because we're already going to be covering a lot of different topics in this video. We're going to basically start from scratch and just talk about setting up your Rust toolchain and getting all the necessary crates or libraries installed to your Rust application. We're going to create a brand new Rust application from scratch. We're going to set up credentials. So we're basically kind of pretending that you're starting from scratch, regardless of what platform. If you're using a Linux desktop, that's fine. If you're Mac OS desktop, that's fine. Windows desktop, like what I've got here, that's fine as well. But there's going to be a lot of different concepts here. So that's why I want to keep things relatively simple and just focus on the synchronous Converse API rather than streaming response tokens back to the Rust client application that we're going to build. But as you can see in the request syntax here, this is the body or payload that you can specify. And all of this body and payload is all kind of objectified in the Rust data model thanks to the AWS SDK for Rust. So you don't actually have to manually construct this complex JSON body. There's actually function calls that you can use in the AWS SDK to set each of these properties using an appropriate data model so that you have a little bit stronger typing around each of the key value pairs that you have in this JSON body. But the point that I wanted to make here is that there's a lot of different settings in this request. So there's this additional model request fields. Well, what does that mean? Right? Well, you'd have to kind of drill into the documentation, and then you'd have to, follow this link over to the user guide to understand some of the unique parameters that are available depending on which model you're using. So if you're doing Claude, you'd want to look at the Claude documentation to see what custom parameters are available, or, what is guardrail config? Well, in order to use that, we'd have to understand what guardrails are in Bedrock. So, we're going to leave that out because that's not required. Neither are these optional additional model parameters up here. There's also this optional inference configuration. If you drill into that, that allows you to specify the maximum number of tokens that can be in a response, just to help you prevent getting massive responses that end up costing you lots and lots of money, because you actually pay for Bedrock based on input and output tokens. If you check out the pricing page, there's some other options in here like the temperature. So how much randomness do I want to have in my model response and things of that nature. There's also the messages down here. So this is actually where we're going to feed in some content. This has something called a content block, and we can pass in an array of content blocks. And this is basically where we pass in the query that we want to send off to the language model. So even though technically the messages section is not mandatory here, this is what we are actually going to be using because we want to be able to kind of act like we're typing into the model and then getting a response. Just like you would if you go over to the console here, you can actually do under playground right here, you can do a chat with a text model, and we could choose, something like Claude Haiku, apply that. And so now right here in the AWS console, we can ask a simple question. So like, what is the 40th state to join the USA? We can run that. It's going to use the Claude 3.5 Haiku v1 model, and it looks like that is Colorado in 1876. So we want to be able to do this same thing where we send a query as input tokens and then generate some response tokens from the model, but we want to build a custom user interface from a Rust client application, right? That's why we use the Converse API. And so when we feed input tokens in, we feed them in under this messages property here, which has an array of content blocks that we then feed into it. So we'll take a look at how to do that. There's also this performance configuration object here. So you can choose, at least for certain models, you can choose a latency optimized model. The default is just to use a standard model. So I really wanted to just kind of focus on the fundamentals here and keep things as simple as possible for starters. And then once you understand the basics of using the Converse API, then you can go out and explore things like latency optimized models or additional model parameters for specific models that support it. You could also check out how guardrails work in Bedrock, and you could use guardrails if you'd like to. So we're going to focus on some of those fundamentals for starters, and then feel free to kind of go out and explore separately if you'd like to. Now, the question is, how do we actually get started? Well, we're going to need a whole bunch of tools and hardware. So even though Rust is a great language for producing lightweight binaries, the hardware requirements as a developer and for creating a build environment when you're compiling an application, the requirements are actually pretty hefty. And there are some parameters that you can specify to kind of work around that and run compilation processes on some lower end systems. But you're generally going to want a system that has more CPU cores. So on my developer workstation here, I have a 16-core CPU with 64 gigabytes of DDR4 memory. I would recommend having at least at the bare minimum 8 gigabytes of memory. You probably want more like 16, probably 32, ideally 64. And if you're building really complex applications, you may even want to go higher than 64 gigabytes. But applications are RAM hungry these days, and that's also true for Rust compilation as well, because it's multi-threaded. There's lots of different tasks kind of happening in parallel when you're compiling a Rust application. So you do want to have a beefy system. And one thing you can actually do is set up an EC2 instance in AWS and then just use Visual Studio Code on your local development system to connect up to that Linux server. So if you're on a lighter weight laptop that maybe just has maybe a dual core processor, kind of lower power system with maybe 4 or 8 gigs of memory or something like that, you can still run your editor locally and have a great development experience, but you're actually doing all of your compilation work and all your coding work up on the remote cloud server. So that's a nice option as well. But I'm going to be doing all my development locally, at least for this particular video. So one of the first things that we're going to need is the Rust toolchain. So that's called Rust Up. So if you don't have the Rust toolchain installed, you'll need to make sure that you install that. Just go to rustup.rs. That's the website for it. And then you can copy the script here. That'll install the Rust Up installer, and that will get the Rust Up toolchain installed on your system. The other thing that we're going to be using is Microsoft Visual Studio Code. So this is a cross-platform editor from Microsoft that is extremely powerful. It's highly extensible as well, so you can run it on Mac OS, you can run it on Windows, you can run it on Linux, and there's all sorts of third-party extensions that you can install, including an extension called Rust Analyzer for VS Code. And what Rust Analyzer does is it gives you a lot of advanced capabilities as you're developing. This is basically, I would consider this an essential for any Rust developer, unless you really know what you're doing. This provides auto-completion, or IntelliSense, they sometimes refer to it as, and it just makes writing Rust code a lot easier because it can auto-complete different things for you, and you don't have to explicitly type everything out hand by hand. So this is a huge time saver. It's also very reliable. It's highly reviewed. It's very popular. But again, because it relies on the Rust toolchain, it is a pretty heavy extension. So anytime that you add new dependencies in, it has to be able to index those and pull in all the metadata from those crates or libraries that you're adding to your Rust application. So make sure that you have a beefy system to run the Rust toolchain, including the Rust Analyzer extension on. I'm also, because I'm on the Windows platform, I am also using PowerShell by default, but I actually prefer to use PowerShell natively on Mac OS and Linux as well. It's an object-oriented shell. I'm not really going to be getting into any PowerShell specifics, but I do use that as my shell in VS Code. So just be aware of that there's a lot of benefits to using PowerShell. And we are also optionally going to be able to use something called Docker Desktop. And I'm not going to be using Docker Desktop in this particular video, I don't think. But I do generally like to spin up containers, Linux containers, using Docker Desktop to develop Rust applications inside of, because it helps keep everything kind of isolated within that container. So any tools that I need to install, any dependencies I need to install, I can just install into that container. And then if I ever have any kind of weird problems that I can't resolve in the future, I can just kill off that container and just rebuild a brand new container. And I don't have to worry about reinstalling my operating system or, having conflicts between different versions of tools and everything. Docker just makes life a heck of a lot easier. And there is actually, on the Docker Hub, there is a pre-built Rust container image. So if we go to hub.docker.com and just do a quick search for Rust out here, there is a pre-built Rust container image that has the Rust toolchain pre-installed. So you don't have to install it. You can literally just use this container image to spin up a new Docker container. And it has the Rust compiler, the Cargo CLI tool that's used to manage Rust projects, and all the other tools that are part of the Rust toolchain. So that is definitely an option. And I do generally like to use that, but just to keep things, again, a little bit simpler, I am going to leave Docker out of the picture for this particular video. All right, so I actually have the VS Code editor already installed and the Rust toolchain. So if you don't, feel free to check out those resources that we just reviewed. But I am going to go ahead and open up my terminal here. And we are going to go into a project directory, and we'll just use the Cargo CLI. So I'm running cargo 1.85, released on December 31st, 2024. And this is going to allow us to create a new project. So we'll create a project called AWS SG Bedrock Converse. And then I'll just run code, which is the binary that you can use to launch VS Code from the command line. And I will do star converse tab to autocomplete that. That is kind of a feature of PowerShell, I think, to autocomplete with a asterisk there. And then we'll just go ahead and launch VS Code into that brand new scaffolded project directory. So that's how you create a new Rust project. It's really straightforward. But because we're going to be working with AWS APIs, one of the first things that we need to do is set up our credentials. And one way that you can accomplish that is by going to the IAM service, and we'll create an IAM user with access to the Bedrock APIs in AWS. So if we go over to IAM users here, I'll just go ahead and establish a new user. I'll call it Trevor Bedrock Converse API video. So it's kind of self-explanatory. And then I am going to say attach policies directly here. And if you do that, there is a built-in policy. If you just search for Bedrock here and then say filter by type, we want AWS managed policies. These are policies that are just built in from AWS directly. They have a Bedrock full access. So this will provide access to all the different Bedrock APIs. So feel free to explore exactly which permissions that has. There's also Bedrock read only here as well. So that has Bedrock get and list, but it's not going to have access to Bedrock converse, which is the one that we are going to specifically need access to. So you could choose Bedrock full access here, but that's very permissive and it gives you access to a lot of things that you may not want a user to have access to. So one thing that we could do is to just craft a new inline policy. So one of the things we can do is just say, we'll just say next on the user here and then say create user. And so it's not going to have any permissions right now, but then what we'll do is go back into the user. And for the permissions policies here, it doesn't have any permissions right now. So even though the user exists, it can't do anything. So we'll say add permissions, and then we'll just create what's called an inline policy. And the inline policy is basically a policy that's just embedded directly into the user. And so you can't share that policy with other users or roles. You can create what's called a managed policy here, or sorry, a customer managed policy. And then once you define that policy, you can attach it to different users and attach it to different roles. But if you want everything to be kind of self-contained so that when I delete that user, that policy just disappears with it, you can create what's called the inline policy. So we'll go ahead and say define an inline policy. And then we're going to craft a very, very granular policy that only allows access to the Converse API and probably Converse stream just in case. So what we'll do is choose the service, which is Bedrock. And then which action do we want to allow? Well, we can actually do a search for it because there's a lot of different actions available. And so the service here actually, I think is not supposed to be Bedrock. Let's go ahead and cancel that really quick and try it again. So let's do Bedrock. And then let me see if I can figure out which permission it is here really quick. And if you can't find exactly which permission it is, what you can do is just search the AWS documentation here for Bedrock Converse API in IAM. And you should be able to find some documentation that refers to which particular permission is required. So sometimes you can just search for action here, and I'm not seeing it specified in here. So I think what I'm going to do in this particular case, because I thought that it was going to be an operation right here under Bedrock, is I'm just going to go ahead and grant the Bedrock full access for now. But that is going to allow permissions to a lot of different services. So we just want to make sure that we're very sensitive with our credentials and that we're not accidentally leaking those credentials and allowing access to all these different capabilities inside of the service. So yeah, I'm not really sure where that Converse API is in the IAM editor here, but let's just go ahead and say add permissions, and we'll attach the managed policy. So attach policies directly. and we'll search for Bedrock as a AWS managed policy, and we will enable that one. So that has access to Bedrock Star, which is good. That should include the Converse API. And it has access to a whole bunch of SageMaker related things as well, but we shouldn't need to worry about that. Okay, so once we attach that policy to the IAM user, the next thing we need to do is generate the credentials that we're going to use to access the service from our local application. So to do that, you'll go to the security credentials tab on the IAM user itself, and then you'll say, I want to create what's called an access key. And then just click on other down here. And then for the description, I'll just say Rust application Converse API and say create access key. And then that will provide the access key, ID, and secret access key. And those are the credentials that we use to authenticate as this IAM user that has the Bedrock permissions. So now there are a couple of special environment variables that are supported by all the different SDKs for AWS. And what I'm going to do is create this special file called a .env file. So it needs to say .env as the file name there. But then what you can do is just set a whole bunch of variables, environment variables. So we'll say access key ID, AWS secret access key equals. And you want to make sure you paste those in the correct order. The access key ID is going to look something like this. And then the secret access key is going to be a kind of a mix of characters like this, but typically the access key ID starts with AKIA or something similar to that. And then the other thing that we want to do is set a region. So we can do AWS_region equals US West 2. And that's typically the region that I'm operating in the AWS Management Console, but there are plenty of other regions supported by the Bedrock service. So just make sure that you are choosing one of these regions here. And also, if you go down to model access here, you do have to make sure that you activate these models for the region that you're operating in. So if I activated access to, let's say, Claude 3.5 Haiku in the Oregon region, but then I switch and I go over to, let's say, US East 2 instead of US West 2, then I have to go and make sure that I reactivate access to all of these different models. So that is a per region thing that you need to pay attention to when you're working with the Bedrock service, is which region did I enable model access for each of those models in the AWS Marketplace. All right, so now that we've got that all set up, we are going to go ahead and write our Rust application. And part of our Rust application is actually going to include reading this env file here. So we have our cargo.toml file in our Rust application because we used the cargo CLI to create the new project. And as you can see right now, we don't have any dependencies declared in our Rust application. So there are going to be a bunch of different crates that we're going to need access to. For starters, in order to import this special .env file here that has a bunch of different environment variables that we want our application to load when our application starts up every single time, we want to dynamically read this .env file so that any user who's going to use our application can create their own .env file with their own credentials and specify these dynamic values. We obviously don't want to share these credentials with any other users, right? So to do that, there is a crate in the Rust ecosystem called .env. So if we go out to crates.io here, there is a crate called .env, just spelled out just like that. And this is going to allow us to import very easily that .env file. So we can just call .env, and then .env is the function there, and that will simply load, it'll parse and load the environment variables for the Rust application. So let's go ahead and go to our terminal down here in our project directory, and we'll say cargo add.env into our project. And then over in our main.rs file, this is the entry point into our application. So when we run our Rust application with cargo run, we are going to initiate this main function in the main.rs file here. So what we'll do in the main.rs file is just say .env, and it actually just did an import there. So we'll go ahead and just say .env, and then we'll go ahead and unwrap that result. There's actually a more rustic way to do that. and we'll say let result equal that. And so we have this result type here that either returns a path buff or an error. And so what we can do is say match result. And if the result is an error, then we'll say print line error occurred while loading the environment variables file. And then we'll, for the OK, so if the result was successful, then we are going to go ahead and just continue. So we'll do a fat arrow there, and that needs to be a comma at the end of this line right here. So we'll have the error condition. It'll just print out an error message. But if it's OK, we'll use the underscore to discard because we don't need to parse out this path buff. I don't really need access to that path buff. So I'm just going to discard it with the underscore here. And we could just say print line successfully loaded the environment variables file. And then put a semicolon there because that is inside of a code block. And so, yeah, so this will just basically load the environment variables. And then if we wanted to, we could say print line, the current region is, and then put a placeholder with the brackets, curly brackets there. And then we can use the standard library, standard env, and we'll say get the var. And which var do we want? Well, let's get AWS region. And then that also returns a result here, but I'm going to assume for the sake of example here that it always exists. Of course, it may not, but I'm going to assume it exists. So we'll just unwrap the result, which is going to give us the final string and feed it into this string template. So if we just run this really simple application, all it's going to do is say, hey, I successfully loaded the environment variable file, and the current region is US West 2. So now, if I wanted to change the region that I am targeting, I can simply come in here and say, I want to target US East 2 instead. And if we rerun the application, you can see we're now targeting a different AWS region. So that's the good way to load variables here. The .env file does not get checked into source control. So you'd want to go into .getignore here and make sure that you exclude the .env file from your project so that you don't accidentally commit it to your source control repository. You want to have some kind of documentation in your project to instruct any users who are going to use your Rust application after you're done building it that they need to go out and create this .env file, and you need to tell them which items to add into that file and how to generate the credentials and set up the policy permissions and all that kind of stuff, right? Okay. So now that we've got that set up, the next thing that we're going to want to do is to create a simple function that allows us to call out to Bedrock. So what I'm actually going to do, rather than putting everything inside of main.rs here, I am going to create another file here called bedrock.rs. And inside of this bedrock.rs file, this is where we're going to create our main application loop. What we're going to do is we're just going to loop constantly with an infinite loop in Rust, which is really easy to do with the loop keyword. And we're just going to prompt the user for an input query. And then we're going to send that off to Bedrock, and then we're just going to print the response, and then we'll just continue to do that iterative operation. So what you can do in Rust is you can create a separate module by simply declaring a different file. And then in your main.rs file here, you can reference that with mod bedrock. And then once you've imported that module into your main.rs, then at the end of our application here, we can call out to that bedrock module and call one of the functions inside of it. So we need to start by defining a function. So let's do pub fn, and we'll call it bedrock loop. You can call the function whatever you want to. I'm just going to call it bedrock loop here. And so we'll call out to the bedrock module here. And you do need to make sure that you have the pub keyword here. And so what that does is it makes sure that any other source files that are referencing this bedrock module can actually see this bedrock loop function. If I don't put that pub there and I try to call bedrock loop from the main function, it'll say bedrock loop is private. And that's one of the reasons that Rust Analyzer is great, because it actually gives me that feedback to tell me exactly what the problem is so that I can go fix it very easily. So if I go back to bedrock.rs and make that function public from the module, then main.rs can actually see that function and successfully call it. So that error, as you can see, just disappeared. All right, so in the function here, what we're going to do is just say loop and put some curly braces here. And inside of here is where we're going to do all the different work that we're going to do. Now, one of the things that we need to do as part of our setup process here as well is to include the Tokyo crate. Now, Rust has support for async, where you can do lots of different tasks kind of in parallel, or you can have lots of different active tasks on a single thread, but only one task can actually use a thread at a given time, right? So Rust has this built-in notion of async, but it doesn't have a built-in async executor. So if you are building an async application, which all the AWS SDKs are built around async, so you kind of need that, there is a crate called Tokyo. This is a very popular crate in the Rust ecosystem, so I would recommend just getting used to including it in most of your applications. Unless you're writing something that's just completely synchronous code, I would just make sure that you include the Tokyo crate here. But this is really easy to add. So what we can do is say cargo add Tokyo -- features full. And then in our main.rs file here, we want our main entry point to be an async function, which normally you can't do because Rust doesn't include an async executor out of the box. If I just try to run this right now, it's going to say, hey, the main function is not allowed to be async because we haven't declared a async runtime executor. So what we're going to do now that we've imported the Tokyo crate into our project is we're going to add this macro here. So it is # square brackets Tokyo ; main, and that is going to tag our main function here as being an async function. So now we can use async there as our entry point, and the Tokyo executor will handle execution of our entire Rust application. And that will now allow us to use all of the async AWS SDK crates or libraries inside of our application. So what we're going to do over here in the Bedrock loop function is we are going to prompt the user for input. So we'll just put in a placeholder here as a comment and say prompt user for a prompt. And then we want to basically run the Converse API call and then print out the response from Converse API call. So that's basically all we're going to do here. We're just going to continually loop in an infinite loop, and we're going to say prompt the user for a prompt to feed into the language model, run the API call against the Bedrock APIs, and then print out the result, and then just keep doing that. So we're going to need a couple of crates to accomplish this. If you've watched any of my other videos on working with the AWS SDKs, you are probably familiar with the AWS config crate here. So this allows us to do all of our kind of client setup. So we can specify things like which region do we want to use. We can specify which AWS credentials profile do we want to use if we're using an AWS credentials or AWS configuration file. There's a lot of different configuration options in the AWS SDKs for any different programming language out there. So this is going to be something that you definitely need in order to work with any of the service APIs. Then there's also, if we search for Bedrock SDK, there are several different crates. Remember how there's different kind of groupings of APIs in the Bedrock service? Well, there is the crate for just the core Bedrock APIs. But then if we check it out, there's Bedrock Data Automation, there's Bedrock Runtime. This is actually the one that we want right here. So we'll go ahead and copy the name. Then again, there's Bedrock Data Automation Runtime, Bedrock Agent Runtime. So again, the one that we want is Bedrock Runtime because we need that Converse API. And if you recall from the documentation for the Bedrock APIs, which it looks like I've currently closed, the Converse API is part of the Bedrock Runtime, not the Bedrock crate. All right, so we're going to go down to our terminal again and say cargo add AWS-config. We're also going to add this parameter here called features behavior version latest. I would just generally recommend always adding that to your application. There is kind of a unique system that the Rust SDK team at AWS has where they can kind of track different behavior versions as behaviors change between different versions of the SDK. But the vast majority of the time, you really are not going to need to worry about that. So always add the AWS-config crate with that features behavior version latest parameter right there, and you should be good to go. Then we're also going to say cargo add, and we're going to paste in AWS Bedrock runtime and go ahead and pull in the latest version of that. And so now we've got the crates we need. And the one other thing that we need to do for prompting the user for a prompt is we are going to pull in another crate called the inquire crate. And this is a very simple community open source library that allows you to do very, very basic, simple prompting in a terminal-based application. So we're not going to build any kind of graphical front end. We're just going to use an interactive prompt from the terminal. And so what we can do is we can prompt the user for generic text input. We can prompt the user to select a date from a calendar. We can ask the user to select from a list of items. We can allow them to choose multiple items from a list. We can give them a simple yes/no prompt. So really basic things like that. We can also do secretive password prompts here that will mask a password that's typed in. So this is a really nice crate that's just easy to pull in to your project, and this will allow us to prompt the user. So we'll go ahead and do cargo add inquire. We don't need to specify any of the additional features here. We'll just use the basic, whatever the default features are. And I think that's all of our dependencies. I don't think I am forgetting any at this point. All right, so for prompting the user, we are going to call out to the inquire crate. So we've got inquire, and then we are going to say text because we're going to prompt the user for some generic text input prompt. And then we're going to say new. And this is the prompt message that we want to present to the user to say, hey, what do you want us to enter? So we'll say, please enter a question for Claude. Okay. And then we have to call the .prompt function in order to get that to actually present to the user. And then the result here, we'll say prompt result as a variable. And this is going to give us a result object in Rust. So if there's some error that occurs while it's trying to prompt the user, we'll get an inquire error. Otherwise, if it's successful, then we'll just get a string containing the text that the user typed into the terminal. So what we'll do is say if prompt result is an error, so if for some reason we get some kind of error, then we're just going to call continue. And that's a Rust keyword that will just basically skip everything else in the loop down here. It'll skip all that, and then it'll start the loop from scratch again. So it'll just start prompting the user again for something. But if it's successful, then we can call the unwrap function on this prompt result to get the underlying string in that result object. All right, so for the Converse API call, before we actually get to the API call itself, we have to construct the AWS SDK client. And I typically like to create a separate helper function because it's just a couple lines of code that we need to use here. So what we're going to do is just say fn get bedrock client. And then this is going to return. So we'll do an arrow here and say this is going to return an AWS Bedrock runtime client object. And then inside the body of this get bedrock client function, we're going to start by creating what's called an AWS configuration from the AWS config crate. So we'll say let AWS CFG equal AWS underscore config. And then we'll say from env and say dot load. Okay, so that's going to use the environment variables that we set, the access key, the secret key, and the region to load the configuration, and then that outputs a future. And in Rust, a future is what we use for async task tracking. So we actually have to call .await to get the SDK config object. All right, and this also is only supported inside of async functions. So once you go into async land, you pretty much always have to stay in async land. So let's designate our function here, get bedrock client as async. And we're also going to do the same thing up here with bedrock loop. So we're going to say pub async fn bedrock loop. And because we turned bedrock loop into async, we have to go over to main and say dot await down here when we actually call it. Otherwise, Rust will never actually call the bedrock loop function from our main entry point. Okay, so now what we need to do is just return a client object. So to do that, we'll just say AWS SDK Bedrock runtime, and then we're going to say client, so double colon client, and then do a double colon new. And when you construct a new client object for the service crate that you specified, so this could be the S3 crate, it could be the Lambda crate, it could be DynamoDB crate, for example. But in this case, we're just calling out to the Bedrock runtime crate, creating a new client. What we can do is specify a borrowed SDK config, which we have right here. So we'll just say borrow with the ampersand and then say AWS CFG. And we don't want to put a semicolon at the end because in Rust, when you don't put a semicolon at the end, whatever object is constructed as part of this expression here is actually returned as the function return value. Now, another syntax that you can use here if you want to be more explicit about the return value is you can put a semicolon at the end, but if you do that, then you have to add the return keyword up front here. So this is a little bit more of a traditional programming approach where you're explicitly using a return keyword, but the rustic way of doing it is to simply construct the object, leave the semicolon off on the very last line in the function, and then that is going to return whatever you specified from your return type here, or it should. If it doesn't, it'll throw an error. Okay, so now this function we can just call from up here, and we can say let br client equal get bedrock client dot await. And so now this variable up here has access to the bedrock client object, and we can now use the bedrock client object, or I should say bedrock runtime client object, to call the Converse API. So let's do a br client dot converse. And remember that with the Rust SDK, if you've watched any of my other AWS SDK for Rust videos, you'll know that in order to construct an API call to AWS, when you call .converse here, it doesn't actually send the request until you call the .send function, which returns a future. So you actually have to call .await. But anything that you put before calling send here is going to allow you to configure the request parameters before you actually send the request. So referring back to the AWS Bedrock documentation, API documentation, let's do Bedrock API docs and go to the API reference, go to actions, go to Bedrock runtime, and then go to the Converse API right here. So all the different functions available on that Converse function are going to allow us to configure all these different parameters here. One of the first things that we need to specify is going to be the model ID. And the raw REST request, which we don't have to worry about because the Rust crate wraps all that stuff for us. But one of the things that we have to feed in is the model ID. So that just happens to be part of the request query string here, rather than being part of the actual body or payload of our HTTP request. But again, we don't have to worry about that because the SDK handles all that for us. We just have to make sure that we specify the model ID and then any other inputs like the messages here that allow us to feed in the prompt. Okay, so for Converse, we are going to say dot model ID, and then that'll take a string input here. And if you recall, we talked about how to get this. We'll go back over to the Bedrock console and we'll go to the model catalog. And again, you could prompt the user using the inquire crate for different models. I'm just going to hard code a single model for now, but feel free to, prompt the user of your application to select a model before they actually process a request. So model catalog, choose a specific model. I'll just use the 3.5 Haiku model. And then we're going to copy the model ID from right here or from down here, either way. And then now that we've got that value, we can just feed it in right here. And I'll put that on a new line. And then after specifying the model ID, we also need to call the .messages function. And this is going to take a message construct as input. And this is going to allow us to actually feed the user's prompt that we are prompting for up here, that string value. That'll allow us to feed the string value as input, as an input message for the language model to respond to. So we actually have to work backwards a little bit here and construct this message object before we can actually feed it into the messages function here that's configuring the HTTP request before we send it. So let's go somewhere above that line and let's do let message 01, because you can have multiple messages. Remember, in the documentation here, messages is an array of content blocks, or it's an array of messages, and then each message can actually have an array of content blocks inside of it. So there's a couple of layers there, but we're just going to say let message 01 equal. And then if we do message here, you'll see it, the Rust Analyzer extension automatically finds all of the different types that have message. But in particular, we are looking for this one right here, which is under the Bedrock runtime crate types and then message. So it will automatically add the necessary use statement right up here, so that rather than having to add this entire prefix, crate types, and then message, we can just reference it as message down in our code here. Otherwise, if you don't have that use statement, if we take that out, then Rust doesn't know what the message type is referring to. So you could just specify the entire path to it there, but in Rust, we have the use statement so that we can simplify our syntax down in our actual functions. So we want to use the message type, and that allows us to use it anywhere inside of that module. So we'll say message builder. This is a pattern that you'll see on a lot of the AWS SDKs for various services, is if there is a custom data type, like this message data type, it'll have a builder function oftentimes on it. And then when you create the builder, then there are functions that you can use to configure the different properties on that resource. And if you look at the API documentation here, each message in the array of messages has content, and it also has a role. Now, in the context of language models in the Bedrock service, large language models more broadly, there's a couple of different types of roles. There's the user role and there's the assistant role. So the user is you, the person that's actually typing some kind of text into the prompt to get a response from the assistant. The assistant is referring to the language model itself. So anytime that we are using the Converse API to feed some input into the assistant, we're generally going to want to use the user as the role for the message. Now you can get into building kind of a back and forth where you have, maybe a user message, then a assistant message, and then another user message, and then another assistant message. But in this particular case, we're just going to keep things really simple and just have a user message. So when we do .role, this allows us to use the conversation role type here to select if it's the user or the assistant role. So if we type conversation role, you can see it is auto-completing this there, and it's kind of rolling off the end there, so it's actually finished right here. But this is the assistant. So this is an enumeration, I believe, and then there's two different roles here. There's the assistant, and then if we go down to this one, this is the user. So we want to choose user because we are passing in a message as the user. And then we also want to call the .content function. So let's put this on a new line. And then on a new line, we'll say .content. And then to configure the content here, we need to specify a content block. So again, the crate Bedrock runtime, AWS SDK Bedrock runtime, under the types module under that crate has a content block type that we need to use to construct one of these content blocks. So before we create the message, we're going to create another variable and say let content01 equal content block. And again, that's going to automatically add the content block as an import under the use statement here. And so we're importing two different types now. We're importing message and we're importing content block. And under the content block, this is also an enumeration type that has several different variants. So in Rust, an enumeration has different variants. And so as you can see, when you're feeding input to a language model, oftentimes you can upload files, right? You can attach a CSV or a PDF or other types of files, or maybe an image file like a PNG or a JPEG or something like that. And so this enumeration here, called a content block, is allowing us to specify what is the type of data that you are attaching to the input that you're sending off to the language model. And in our particular case here, we're just going to focus on the text variant because we are feeding some text as a prompt to the model. Now, if you want to go build out the functionality to attach files off your local file system or PDFs off your local file system or CSV files or any other types of assets like that, feel free to explore that as well. But for the sake of example, just to keep things simple, I'm going to focus on the text block here. So we are going to feed a string value into this enumeration variant, and that's going to be the text that we prompted the user for up here. So what we'll do is just go ahead and say prompt result dot unwrap, and that's going to unwrap the string that was successfully extracted from this prompt using the inquire crate over here. So we're going to construct this content block object using the prompt result. And then we're going to create this message builder. We're going to call the role to specify that it's the user role. We're going to call the content function, and we are going to pass in this content01 as the input to that function. And remember, the message has the ability to have multiple content blocks. So you can pass in multiple messages as input to your prompt in the Converse API, but when you construct a message, that each message can actually have multiple content blocks. So keep that in mind, but we're just going to use a single content block in a single message as the totality of the input to the large language model. So if you want to make a more advanced application that has different types of content blocks and multiple content blocks and multiple messages where you're going back and forth between the user role and the assistant role and all that sort of stuff, feel free to do that. That's totally up to you. But we're just going to keep things simple and have a single message with a single content block that using text as the input type. Okay, so now we've got this message builder, but we can't use a message builder and pass it into messages down here. So again, this is a pattern that you're going to see in AWS. When you construct this builder, you have to call the .build function to actually get the underlying message object right here. And that's actually wrapped in a result type, which is a Rust concept. So what we need to do is go down here and say, all right, the input to messages here has to be a message object. So how do we get that out of the result? Well, we can call the unwrap function. And so we do message01 dot unwrap. And unwrap can fail, and that'll cause your application to panic in Rust. So typically what you would do if you want to write more robust application is you would say match message01. And then inside of the match block here, just like we did up here with the prompt result earlier, or actually over here in main.rs, when we called the .env function here to load the environment variables, if it was successful or okay, then do this. If for some reason something failed, then run this error handler block, right? So that's technically how you're supposed to handle things in Rust, but for the sake of example here, and just to kind of keep things moving forward, I'm just going to do message01 dot unwrap. Just like for the prompt result up here, I am calling unwrap. The difference in this case, though, is that I actually have a handler statement right here that says if there is an error trying to parse it here, then skip over and go to the next loop. So this prompt result unwrap can't actually panic because if there was an error, it would already be handled up here and it would totally skip over this down here until the next prompt was provided by the user. So there's kind of different ways of handling that inside of your Rust code, but that's kind of how you would do it typically, is either using the match block or by kind of adding in this type of if conditional block just to say, hey, if there was an error, go do something else. Okay, so now we've got model ID and messages. And as we talked about, there are lots of other things we could configure. We've got inference config, we've got guardrail config, all this other stuff, right? I'm not going to focus on that for now. I want to keep things super, super simple so we can literally just take a text input, feed it to the language model, and get a result. So I think that model ID and messages are all we need. We should not need anything else at this point. So remember, with the request builder here, we have this Converse fluent builder. We have to call .send.await. We talked about that a couple minutes ago. So let's do .send.await. And then this is going to return another result. So we'll say let Converse result equal the output of sending and awaiting the async future that was generated from this send function. So the .send function actually builds the request as an async future, and then await is the Rust keyword that we use to actually say, okay, Rust, I want you to go ahead and execute this now, right? And that causes the async executor, which in this case is Tokyo, to actually drive that future to completion and actually extract an output from it, which is this Converse output or an SDK error. It's a result type. So now that we've got that result, we want to do a match statement. So we'll say match Converse result. That's our input to the match statement. And we want to compare that and say if it's an error, we'll discard the specific error message. Actually, that's not a good idea. I'm going to capture it with the error variable there. You could call this error 01. You can call it whatever you want to, but whatever variable you specify in those parentheses there, that's what the SDK error is going to be assigned to. We'll do a fat arrow, so equals greater than, and then we are going to say print line, and we will do a placeholder here with a colon question mark, which will invoke debug output, and then we'll pass in the error variable. And then we do comma, and they say, okay, so if the result was successful and not an error, then let's use the data variable to capture the Converse output, and we'll do a fat arrow and feed that into a Rust block. And inside of that Rust block, we're going to say print line response was colon, and then a placeholder. And what do we feed into the placeholder this time? Well, now we have this Converse output object right here. Sorry for that pop-up that keeps showing up there. The pop-ups are helpful. I know it's distracting during videos. I've gotten comments about that before, but unfortunately, they are helpful most of the time. So I'll try not to hover over it while I'm talking about it. So on line 28 there, we have that data variable that is extracting Converse output from the result type that we have up here, right? So if it's an error, it's going to extract this SDK error from the result, and it'll just print out the result on the error from that on line 27. But if Converse was successful and a response is received from the language model in the Bedrock service, then the data variable gets populated. So what we can do now is take a look at the documentation again and say, okay, well, what does the response data structure look like, right? So we can scroll down, way down here, and say, all right, the response structure looks like the following. It's an HTTP response, type is JSON, and here are all the different fields that we have. So there is, if you want to get into the nitty-gritty details, there is this trace argument down here that shows any applied guardrails and stuff like that. We're not going to focus on the trace right now. What we care about, we also have this usage down here, by the way, that says how many tokens were input, how many tokens were output, and what is the total number of tokens. And that can help you to calculate how expensive a particular query was. So not to get off on a tangent here, but if we search for Bedrock pricing for AWS and go down here to the pricing details, and then let's find the Anthropic models here. And for Claude 3.5 Haiku, which is the one that we are currently using, the price per 1,000 input tokens is 8 hundredths of a cent, I think. So that would be 1 cent. And then, yeah, I think it's 8 hundredths of a cent. And then it's 40 hundredths of a cent, or 4/10ths of a cent, same thing, as for your output tokens, right? So your input tokens are pretty cheap, but it's the output tokens that you're paying quite a bit more for versus the input tokens. So these are the two columns that you want to pay attention to here predominantly. It looks like there are some other options here for cached responses and batch APIs. I'm not totally sure what the batch APIs are right at the moment, but yeah, focus on price per input, price per thousand input and price per thousand output tokens. And that will allow you to kind of determine using the usage data from the response about what it's going to cost. Okay, but we don't care about that. What we care about right now is what is the actual response that we are getting from the language model based on the prompt that we fed into it. So that is going to be under output right here. So for output, we are going to get this converse output construct, and then the converse output has another one of these message constructs. So the message construct is actually used to feed into the language model. We feed tokens into the language model with a message structure, but when we get the response back from the language model, we again are going to use that message data structure, but we don't have to construct the message because the message is actually being constructed for us during the response that is being sent back to our Rust application. So again, that message data structure is exactly the same as it was for input, where we have content being an array of content blocks, and then we also have the role down here. So that is what we are ultimately going to consume on this print line statement here. So from this converse output, we're going to say, well, I want data dot output. That's the top level JSON property in the response, but output is actually an option type here. So we have to unwrap the option type. And just like with result types in Rust, the option type, if you try to unwrap an option that is none rather than some, having some data versus having no data, it's kind of like a null value in a way. It's basically going to panic your application if you try to unwrap something that has none. But we're going to assume, for the sake of example, that there is actually some data in the response. So just be aware that's generally not a good practice to just blindly unwrap it. But we're going to do that for the time being. So when we unwrap it, it's going to give us the, looks like the converse output there. The converse output doesn't implement. Okay, so we're unwrapping. We've got data is converse output. Then we've got the output variable, which is also the same type. I'm going to assign it to a variable. So let's say let output equal data dot output dot unwrap. It is actually the same type. That is kind of interesting. So we have converse output, then we have data.output.unwrap. So then we should be able to go say dot, and then we have under output, we should have, oh yeah, so we do have a converse output. So it's kind of confusing because the top level response that we're getting back from the API right there on line 21 is actually a converse output wrapped in result. But then data becomes the converse output from the successful result. But then when we do data.output and unwrap that from the option type, that's also called a converse output. So the naming is a little bit ambiguous there, but just be aware that there are a couple of different converse outputs that we're referring to. One is the top level response, and one is the output from the actual payload response, if that makes sense. Okay, so once we drill into output, then we have dot is message. So we can say, is the output a message or not? Or we can just get it as a message. So we'll say a dot as message. That's going to give us a result type that has a borrowed message. So then we need to unwrap the borrowed message. And now we have a variable output here that is a reference to the message. So let's just say let message response, maybe. We'll call that variable. And so then down here, we can say for that message, we want the message response dot content, right? But the content is actually a vec, or kind of like an array in Rust, It's not the same thing as an array, but it's substantially similar. It's an iterator. And so what we can do is get this vec of content blocks, and each of the content blocks under the message is going to have a different type. Because remember, when we're doing the input message, we had the ability to put in a document like a PDF or a CSV or an image file like a JPEG, a PNG, things like that. Same thing in the response. When we get a response back, this Converse API has to be able to abstract what the response is. Did I generate an image and send it back to the user, back to you? Or did I generate some text and send it back to you? Or generate a document and send it back to you? You know, what exactly is it that I'm sending back to you? Well, in this case, it's going to be a text-based response because we're working with a text model. So what we want to do is basically iterate over each of those content blocks. And so we'll go to .content. We want to iterate over that and basically just print out the text from all of the content blocks. So what I'm actually going to do here is create a for loop. And so we'll say response was, but I'll eliminate that placeholder. And then down here, we'll say for block in message response dot content. So now we're going to iterate over the vec of blocks. And what we want to do is say print line. And then we're just going to put a placeholder here. And we're going to say block dot as text. So we're going to force it to coerce as text. And again, that may or may not be successful depending on the data that was actually returned. But for the sake of example, I'm going to assume that it is successful, and we'll go ahead and unwrap that. And we are going to get this error here saying that the temporary value is dropped while borrowed. So what we have to do is kind of split this into two separate lines. So we'll say let the, let's copy this variable here, message response equal. And then up here, this will be the data underscore output. So we'll grab the Converse output on one line. Then on the next line, we'll do data output dot as message dot unwrap. Put a semicolon in there to make it happy. And then down here, where it is saying cannot move out of message response dot content, which is behind a shared reference. So what we have to do is either clone it, or we can actually just put an ampersand in front of it to borrow that. And then we have a borrowed reference to each content block rather than having duplicated content blocks in memory. So that's a more efficient approach than simply cloning the data each iteration. But you can also do content dot clone, I believe, and that will also resolve it. But I believe that's less efficient than just doing a borrow here. Okay, so for each block in the message response content, because there could be multiple blocks in the message, we want to print out the block as text. Pretty straightforward. I know there's a lot going on here, but it's really just boiling down to the complexity of the data structures, both the complexity of the data structures that are coming from the AWS SDK, but also the complexities of Rust, where you have these result types and you have these option types that handle error cases, or error versus success, or in the case of the option type, you have none or some data. Either I have no data in the response or I have some data. So that's why we have to do all these different unwrapping things and match statements and things like that. So I would encourage you, if you are interested in Rust and you're not familiar with those concepts, make sure that you understand the Rust result type in depth, and make sure you understand the Rust option type as well. And then you'll understand why we're doing all these unwrap calls and things of that nature. Okay, so I think we have a working example right here. And that's pretty much the last step, is just to print out the result from the API. So let's go ahead and try this out. So we'll go ahead and say cargo run. And this is going to compile all of our dependencies, and then it will run our application. Now, one of the things I did want to point out is that in our current code setup here, one of the conditions that we're not allowing for is we're not allowing the user to exit our application. So there's no way for the user to say, hey, I want to leave the application. So we're actually going to have to artificially kill the application from another window. So in VS Code, I can just say split my terminal here. And then I can have a terminal on the left and a terminal on the right. Let me just minimize that a little bit there. And then on the terminal on the right, I can say in PowerShell, get process, or GPS for short. And then I can say get process where the name is containing our project name, which is Bedrock. So I'll just say get process star Bedrock star. And as you can see, we have a process running here. Do I have a horizontal scroll bar? Looks like I don't, but you can see the process ID 58364. And if I bump the font size down a little bit, you can actually see that the process name is AWS SG Bedrock Converse. That's named after our project. And that's because our application is actually running right over here. So what I can do is say get process star Bedrock star, and then I can say stop process, and it'll basically feed any processes it detects into stop process, and that will kill our application over here until we implement some kind of logic to allow the user to gracefully exit our application. So that's one condition that we have not checked for yet, so you're aware of that. But yeah, let's go over here and try our application out. Let me kind of scroll this over a little bit so we have more space here. So as you can see, we have this prompt that says, please enter a question for Claude. And I'll say, what is the 41st state in the USA? And as you can see, it says Montana is the 41st state, blah, 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 right? So this is the response that we are getting from the Converse API. And it's all coming back, I believe, as one content block, because for every content block that we have, we are printing a new line. And it looks like this is kind of contiguously just one big line that's wrapping around. So I believe that in that message response that we're getting, even though technically there could be multiple content blocks, I think we only have one actual content block. And one way that you could check is to basically look at the size of the vec here. So we had in the content property here, it's a vec of content block. And so we could check the size of the vec to see how many elements are in that vec, and that'll tell us how many content blocks were in the message container in the response from the Converse API. But yeah, after we get a response to that question, it loops again, right? And so if we hit escape and cancel, remember, we have some code up here that says if the prompt result is an error rather than a successful string extraction, then continue. So all the code down here is going to get skipped, and it's going to loop around again to the beginning of the loop structure right here. And then it's just going to prompt us again. So we can hit escape there as many times as we want, and it's just going to skip over all the Bedrock code until we actually enter a valid prompt. So let's enter another prompt. So we'll say, what is the capital of Yugoslavia? And give it a second to respond. Yugoslavia was a country that no longer exists. What's it called now? So it looks like that changed. But yeah, we can just ask really any question. So we can say, what is the most popular programming language in the USA? And see what it says. Remember, we're using the haiku model. And so we get this nicely formatted list of programming languages. So Python, JS, Java, C++, SQL, and so on. How popular is the Rust programming language? Oops, I misspelled that. But it'll probably understand my intent from that prompt either way. So it says not as widely used, growing ecosystem, performance and safety, industry adoption, developer surveys, rank it highly. So yeah, you can just plug in whatever prompt you want here, and you can just continue playing with it. You can kill off the process. And if you want to provide the user a mechanism to exit the application, we could say, we could check the text that's extracted from up here. So right now we're just feeding the text directly into the content block right here. So we're doing prompt result.unwrap, but we could actually move that up here and say, let prompt text equal the prompt result.unwrap. And then down here, we could say, take the prompt text as input. But what we could do is say, if the prompt text is equal to exit specifically, and we'll turn that into a string. Let's do dot as, or dot toString actually. And then we can say if it's prompt text, if the prompt text is specifically lowercase exit, then do standard process. This is part of the standard library in Rust. And then we can call exit, and we can exit with code 0 because the user explicitly requested to exit the application. So let's go ahead and run the application again. And this time, if we run a prompt, we can say, what is the 48th state in the US? And see what the model says. It says Arizona is the 48th state. But now if we type exit at the prompt, now it gracefully exits our application. So, you can make little iterative improvements like that. As we talked about as well, you could use the inquire crate to select from a list of models. So if we wanted to say, oh, you can choose from the Haiku model, or you can choose the Sonnet model, or the Opus model, or Claude 3.7 Sonnet instead of 3.5 Sonnet, we could add another prompt here. We could either add it before the loop, so every application session, you'd always use the same model, or we could add it so that every single prompt loop that you do, it prompts you for which model you want to use in addition for the prompt itself. And it's really up to you how creative you want to get with it. So anyways, I hope that this has been helpful for you. We basically went through completely from scratch, built a brand new Rust application. We included the Tokyo async runtime. We loaded our credentials from a .env file here in our project. And then we built a really simple function here that continuously loops. It prompts us for some input. It generates a response thanks to the Bedrock Converse API, and it prints out the response from the large language model. Now, in the future, I would encourage you to also take a look at the Bedrock API called Converse Stream. This is a little bit more complex. It's essentially the same thing as Converse, but it actually streams the messages back to you. And so what you have to do is basically check to see if there's more content in the result and just continuously print out tokens. So that adds a couple of more steps, but I think this video has already gotten long enough. So hopefully, you can explore that on your own, or maybe I'll have a chance to do another video on how specifically to use Converse Stream. But if you enjoyed this video, please leave a like on this video. That helps us to grow our channel. Also, leave a comment down below. Let me know what you learned from this video. Let me know what you think of the Rust language. Let me know what you think of the Amazon Bedrock APIs. I really like them. I think it's really powerful and allows you to build a lot of different things. So I'm curious to hear what you think of it. And then also subscribe to our channel so that you get notifications about future videos that we publish. And also go back on our channel as well. Look at all the historical videos that we've got, because we have a lot of content that covers the Amazon Bedrock service, as well as many other services and specific features within the AWS ecosystem. So thanks so much for watching. Again, my name is Trevor Sullivan, a solutions architect with StratusGrid and an AWS ambassador, and we will see you in the next video. Take care.